in theoretical science. The Dyson sphere is probably the most well-known of all the concepts and theories that are named after him. It's a hypothetical means by which to harness all of the energy potential from a star, and it's a must-have bit of cosmic mega machinery for any sufficiently advanced civilization. Humankind is a long way away from building one, but Dyson Trees are a slightly different and arguably more feasible prospect. On the face of it, their scope isn't quite as all-conquering as the star-taming sphere, but they could still come to be humanity's best hope for a route to other worlds. Dyson Trees grow on comets. At least that's the general plan anyway. Their exact nature hasn't yet been fully decided, but according to most designs, they're proposed genetically engineered plants which can be seeded on and can flourish in ice-laden comets, like the ones on the edge of the solar system. They make use of the water and carbon found in comets. They grow in such a way as to produce their own greenhouse effect even in the vacuum of space, and eventually, once they've spread all over their chosen celestial body, they form a habitable environment for life. Most versions of a Dyson tree involve it having multiple central trunk-like structures, moving through the icy comet and hollowing out a space inside the comet that offers breathable, bearable living conditions. Some designs go further, however, and plant coverage becomes so thick and complete that even outside, on the surface of the comet, there's a chance of breathable air and something faintly resembling a tolerable atmosphere. Clearly, at this stage, Dyson trees can be said to be more science fiction than conceivable reality. There's still so much for us to learn and achieve before we can consider planting them for ourselves. We need to work out how to genetically engineer a plant for space, for one thing, and how to systematically sow those seeds into icy bodies that usually orbit further away than even Pluto. But we are making some progress. Various plants and vegetables have been grown on the ISS before now. In November 2020, for example, astronauts on the space station were able to harvest a total of 20 radishes. In January 2019, we also had the first example of something grown on the moon, although this was inside a closed Earth-like biosphere on board China's Chang'e 4 lunar lander. There's a long way to go between astroecological experiments like these and full-blown Dyson trees, but we are making the first steps. As for specifically targeting comets, we're already a little more advanced. We've sent more than one probe as far as and through the Kuiper Belt before now, which is where so many of the solar system's comets are. What's even more impressive, though, is that in November 2014, the Philae lander, deployed by the European Space Agency's Rosetta probe, became the first spacecraft ever to soft land onto a comet, when it landed onto the Jupiter family comet known as 67P/CG. These days, hitching a ride on a pre-appointed chunk of space ice that's literally hundreds of millions of miles away is something we can do. So what will the future look like if we go in the direction of Dyson trees? How will they change space, and the solar system specifically? And how could they help humanity to achieve even its loftiest space goals? So much of the action does take place inside the Kuiper Belt, as well as in the scattered disk. These far-out regions of the solar system stretch way beyond the orbit of Pluto, although not quite so far as the Oort cloud. These are dark places, and incredibly cold because they're so far away from the sun, but sunlight does reach here. So if in a future time we installed solar panels, then it would theoretically be possible to generate power to the Kuiper Belt and beyond, which would be key for potential human settlement. Crucially for today's question though, both the belt and the scattered disk play host to thousands and thousands of comets, so that's why we'd be heading there. For Dyson trees, it's a planter's paradise. Right now, we never really imagine that these outer regions of the solar system are all that colorful. It's just rocks and ice, and dust, and nothingness stretching as far as the eye can see. But Dyson trees could bring about change and variety. Most sci-fi versions look spectacularly green when viewed from the outside. They're painted as beacons of life, set against the dark expanse of space. In reality, their greenness might not appear quite so bright. They might not glow quite so magnificently, but they would be a much more welcoming sight than just your standard everyday comet. Much would depend on specifically how they had been genetically engineered. Perhaps they'd have tangles of branches crawling across their surface, crisscrossing in unruly jungle-like patterns, or vast sail-like leaves reaching in the direction of the sun even this far away from it. For any hypothetical traveler stuck in their spaceship, a Dyson tree would emerge out of the gloom like a cosmic oasis, an island in the ocean of space. And were we to successfully plant more than one of these things, an emboldened traveler might even go island hopping throughout the Kuiper Belt, from tree to tree, exploring further and further afield. It's not as though Dyson trees wouldn't be isolated, though. The distances between large objects in the Kuiper Belt and the scattered disk still amount to millions of miles. For a hypothetical community living on a Dyson tree, then, it would be no use relying on help from elsewhere. Not unless they also had a means of high-speed travel quick enough to jet between comets, which perhaps isn't all that unlikely at a future time when Dyson trees are possible. Regardless, Dyson trees would need to be self-sufficient, which would be no easy task despite the presence of water, carbon, and other life-enabling elements within the comet. The trade-off for this disciplined and desolate life? For anyone calling a tree their home, they'd also be stationed at a key frontier for humankind, a major border between us and the rest of the galaxy. It could be that the Kuiper Belt gets transformed into Dyson trees and serves as protection for the rest of the inner solar system, with all those on the trees charged with warning Earth and the other planets whenever a comet or asteroid heads in their direction. Or it could be that Dyson trees in the scattered disk serve as final checkpoints for intrepid explorers heading into the Oort cloud, and the people that live on them represent the last of human civilization before the vast unknown of outer space. When Freeman Dyson first proposed these trees in the late 20th century, our efforts towards space travel were generally winding down. Public interest was waning, budgets were being cut, and the International Space Station was far enough for most missions. Today, the landscape has changed. There are multiple space agencies growing in stature all around the world, plus a seemingly endless stream of private companies intent on taking us to new horizons, too. There's renewed talk of building a moon base, moving to Mars, and constructing orbital cities, not just modular labs like the ISS. So against the backdrop of all of this, it could be argued that Dyson trees aren't quite such a speculative concept anymore. In fact, if we ever hope to truly expand across the solar system, then they could be vital. As always, there are cross-contamination laws to keep in mind, so we'd need to be 100% certain that any given comet was lifeless before we brought life to it. There's also the question of gravity, which we'd need some kind of artificial means of regulating if we ever hope to survive. But from there, we could begin to plant comet gardens in space, to make our mark and increase our knowledge, to seed other solar system bodies so that one day they might support us. And these unusually green outposts could even end up teeming with life, unique and vibrant ecosystems growing and evolving, making their own happy way around the sun. If you had the chance to live on one, would you take it? Because that's what would happen if we